So maybe you're like me and you've always been a little bit confused about polar coordinates, spherical coordinates, cylindrical coordinates, and it all just seemed kind of weird. Well, a better way to think about it is for any n-dimensional, and let's just start Cartesian space, you are able to represent it with n minus 1 angles and a radius. Okay, so that gives you kind of the dual to Cartesian. You could say Cartesian is, every axis kind of has its own radius and they're all orthogonal. But then on the other hand, okay, we have all of these kind of coupled angles and we just have one distance. But then you can mix them. So in the case of R3, you can have basically the product space of a circle, which is, one angle radius pair, and then another just Cartesian orthogonal distance. And that gives you a, cylindrical coordinate system. And of course, you can represent any point with any of these. Anyways, the punchline of how you take this to any dimension is that you can just think of the number of possible ways to break up n-dimensional space into different blocks of, angles in Cartesian as really like a partition on the the set from 1 to n where, one is dimension 1 and n is dimension n. But if you want to duplicate, for instance, deduplicate, for instance, let's imagine that we have, normal 3-dimensional space. So we got X, Y, and Z. And we're thinking about the different ways we could do cylindrical things. Well, we could put the, angle radius pair on any of the 3 planes. We could put it on the XY plane, the XZ plane, or the YZ plane, and it doesn't really matter. So, but if you're not interested in that and you're just interested in what is kind of the number of ways that I could chunk up the space, well, then you're talking about the integer partitions. So if you're dealing with n-dimensional space, it's the integer partitions on n that count the number of ways that you could block up the space into blocks of angles and blocks of just Cartesian coordinates. And it gives a really nice duality that basically the partition, and I'll just open a text editor here. Okay, so, let's say we have 3 space. So R to 3. Okay, well, the simplest partition in a way is going to be this. Whatever. Okay, and this corresponds to just Cartesian. So the place where you've split up, each of the n dimensions into its own distance is going to be Cartesian. Then on the flip side of that, the dual side of that is we have 1, 2, 3 like this. And these are called spherical coordinates. So we're going to have, for example, the first 2 dimensions are going to be angles, and then the third is a radius or something like that. Anyways, I hope that explains a fun way to think about all the different ways that you could put together cylindrical coordinates. Like, for instance, if you had R6, you could put in a spherical. You could put in 2 spheres. You can make it spherical, which would be the same. You would have 2 radii and then 4 angles. It's harder to think that way in higher dimensional space, but the math definitely works out. It's just an integer partition on n.